You know, usually when we talk about a massive corporate failure, there's a smoking gun.
Right, like a flagship product launch that just completely misses the market.
Exactly. Or, a supply chain that completely breaks down right in the middle of the holiday rush.
Oh.
Or a rebrand that goes painfully wrong.
Yeah, those failures are highly visible. They're loud.
Right. You can point to them on a quarterly earnings report and, actually quantify the damage, but when you step into the world of enterprise artificial intelligence, that visibility, it just completely vanishes.
Which is deeply problematic when you consider the statistics we're looking at. I mean, we are navigating a landscape where an estimated 80% of enterprise AI projects fail.
80%. That is just staggering.
Yeah, but they don't fail with an explosion. They fail in total silence.
And that silent failure leads us directly into today's deep dive. We're investigating this really frustrating phenomenon that we're calling the ghost in the repository.
Right, it's this scenario where an AI project is, well, it's technically flawless.
Yeah, the math checks out, the predictive accuracy is incredibly high, the data science team is popping champagne, and yet the project is operationally dead.
Exactly. It does absolutely nothing to move the needle for the business.
Yeah.
It just becomes a phantom investment.
Right.
The organization spends months of time, they burn through computing budget, they get the exact algorithm they asked for, and they still walk away empty-handed.
So our mission today is to figure out why these brilliant models are turning into expensive zombies that are just haunting corporate servers.
And we have some incredible source material for this.
We do. We're pulling from a stack of internal tech memos, some really candid field notes on data science pipelines, and a detailed case study from the consumer packaged goods industry to kind of ground this in reality.
Yeah, that case study is really revealing.
Okay, let's unpack this.
Yeah.
Because the core thesis running through all these sources is that the most critical phase of an AI project actually has, well, it has nothing to do with training the algorithm itself.
No, the danger zone begins the very second the project appears to be finished.
Right, the confetti is falling.
Exactly. But that is the exact moment of the critical handoff. And the success or failure of that entire investment hinges on a specific three-word phrase.
The three most dangerous words in enterprise AI, according to the field notes.
Yeah. The model is ready.
I really want to break down why those three words are a project killer. Because on the surface, you hear ready, and that sounds like a cause for celebration.
It does. But what's fascinating here is that when a data scientist says ready, they're speaking a completely different language than the business leaders who actually funded the project.
Okay, so what does ready mean to them then?
Well, we have to look at the environment the data scientist is working in. To them, ready just means the Python code executes successfully on their local machine.
Oh, wow. So just on their own laptop.
Exactly. It's relying on a highly customized personal development environment. It's using their specific security credentials to pull data, and it's running on a pipeline they manually curated just for that one specific experiment.
Okay, so if I'm understanding the mechanics here, it's essentially trapped, the engine runs flawlessly, but only while it's sitting on blocks in the engineer's private garage.
That's a really solid way to look at it, yeah.
And if you try to take it out onto the highway, it just falls apart because it relies on the specific tools and data pathways that only exist in that one garage.
Right. The model lives entirely inside a code repository where nobody outside the data science team can touch it, let alone understand the underlying architecture.
It's completely isolated.
Completely isolated from the live, breathing infrastructure of the business.
I was trying to picture the business impact of this, and imagine you hire a master chef, like an absolute genius of culinary science.
Okay, I like where this is going.
You give them 3 months and an unlimited budget. They source the rarest ingredients, they spend days prepping, and they cook a literal Michelin star meal.
Right, a masterpiece.
It is perfect, but they cook it inside their own locked apartment. Right. And instead of bringing the meal out to the restaurant for your guests to actually eat, the chef walks out into the dining room, smiles, and hands the guests a highly detailed spreadsheet analyzing the nutritional content of the food.
And then the chef just considers the job done and moves on to prep the next meal.
Exactly.
But that isolation, that is where the 80% failure rate comes from. The project was marked as delivered in the tracking software, so the team pivots to a new initiative. But the model was never actually deployed into operations.
Which brings us to the next massive friction point. If the model is locked in a repository, how do the stakeholders, the people who actually need to make decisions, how do they interact with it?
Well, historically, the answer has been a slide deck.
Right. The data scientist runs the model locally, grabs the output, and slaps a chart on a PowerPoint slide.
Exactly.
But I have to play devil's advocate here for a moment. One of our internal memos is titled, "Stop Presenting Results, Ship the Product." And it is fiercely critical of slide decks.
Very critical.
But wait, haven't we always used slide decks to communicate complex data? Why is a PowerPoint suddenly a failure condition for an AI team?
Because a deck is fundamentally static. And, modern business problems are highly dynamic.
Okay, yeah.
When you put the output of a predictive AI on a slide deck, you are degrading a dynamic engine into a static report. You're giving the business a photograph of the past, or at best, a rigid prediction of a single future scenario.
Right, it's a fixed assumption. So if the slide says sales will drop by 10% next quarter based on current marketing spend, that's useful information.
Sure it is.
But the immediate next question from any competent executive is going to be, okay, what if we double the marketing spend in the Midwest tomorrow? What happens then?
And that is exactly where the slide deck fails. The executive can't just input that new variable.
They have to ask permission, basically.
Yeah, they have to send an email to the data science team. Then the data scientist has to pause their current project, open up their local environment, manually adjust the code,
Rerun the whole simulation.
generate a new chart, and email it back. You have just introduced a 48-hour delay into a conversation that should have taken 30 seconds.
That is wild. The model literally has no surface for the business user to actually interact with.
It's a completely broken feedback loop. The business leaders are essentially sitting in the passenger seat, having to politely ask the driver to turn the wheel every time they want to change lanes.
Here's where it gets really interesting, though, because the source material offers this incredibly sharp pivot away from this dynamic. It says a link changes everything.
Yes. Handing a stakeholder a URL instead of a static chart, it fundamentally alters the psychology of the relationship.
How so?
When you give them a link to a live user interface, you are giving them a tool. They can input their own variables, tweak their own assumptions, and instantly see the live predictions recalculate right there on the screen.
So they stop asking, can you run this scenario for me? And they start asking, how do we scale this capability across the entire department?
Exactly.
Yeah.
Because suddenly, they aren't just trusting someone else's interpretation of a black box algorithm. They're actively driving the system themselves.
And that interaction is what builds trust.
Right. And trust is really the only currency that drives actual adoption in enterprise software.
I hear the argument, and honestly, the psychology makes total sense. But practically speaking, this raises a huge red flag for me.
Okay, what's the red flag?
Are we seriously expecting data scientists, like people whose core competency is advanced mathematics and statistics, to suddenly become full-stack web developers?
Right.
I mean, building a custom, secure UI for every single predictive model sounds incredibly slow and massively expensive. Why can't they just toss the code over the fence to the IT department and let them handle the deployment?
Well, you've just hit on the core organizational failure that creates those zombie products in the first place. You can't just toss machine learning models over the fence.
Why not?
Because IT and data science speak entirely different languages. I mean, IT manages infrastructure. They handle server uptime, network security, database maintenance.
Right.
They do not know how to tune hyperparameters or manage the complex dependencies of a neural network.
So IT looks at the Python notebook and says, this isn't a deployable application.
Yeah,
And the data scientist looks at IT and says, I gave you the math, put it online.
exactly. And that gap between the two teams, that is what the industry calls no man's land.
No man's land.
It is the unknown territory between the data science repository and the production server.
Yep.
And surviving no man's land requires a very specific, rigorous type of engineering that neither the data scientist nor the traditional IT admin is trained for.
Let's break down the actual mechanics of crossing that no man's land, because the field notes are very explicit about what is required to go from a local experiment to a live product. It talks about API contracts, containerization, and authentication protocols.
An API contracts is a perfect example to unpack
So
here.
tell me about that.
So when you have a complex AI model written in Python and a business user looking at a web dashboard, those two systems cannot naturally talk to each other.
Right, different languages again.
An application programming interface, or API, is essentially a strict bilingual translator. But building that translator requires defining exact rules, like what specific format the data must arrive in, how the model will process it, and exactly how the prediction will be formatted when it is sent back.
So it's basically establishing a rigid legal agreement between the user's browser and the company's servers.
Exactly.
So the system doesn't just crash if someone accidentally types a letter into a number field.
Right. It handles all those exceptions.
Right.
And on top of that, you have to package the entire model, along with its specific software dependencies, into a digital container, like Docker, for instance.
Oh, so it runs the exact same way on a massive cloud server as it did on the scientist's laptop.
Precisely. And then you have to build secure authentication so only authorized executives can access those proprietary forecasts. I mean, this requires days, often weeks, of focused software engineering.
But the sources suggest that even if you build that bridge, right, even if you successfully wrap the model in an API and put it behind a beautiful dashboard, you still aren't safe.
No, you're not.
There is a concept introduced here that is, frankly, terrifying for any business relying on AI automation. They call it the data drift bomb.
Oh, yeah. Data drift?
Explain the mechanics of this, because it totally shifts how you have to think about maintenance once a model is live.
Well, a machine learning model is trained on historical data, right? It
Yeah.
learns to recognize patterns based on the past.
Right.
But the real world is incredibly noisy, and it constantly changes. Consumer behaviors shift, supply chains face unexpected bottlenecks, inflation spikes.
Things never stay the same.
Exactly. So if you deploy an AI model to make live business decisions, but you don't build a monitoring pipeline to constantly check its accuracy against real-world outcomes, that model will very quickly begin to rot.
It's operating on assumptions that are just no longer true.
Exactly.
I'm just imagining a pricing algorithm that was trained heavily on data from, like, 2019. It learned all the normal seasonal trends.
Right, the pre-pandemic world.
But if you let that run unsupervised during the massive supply chain disruptions of 2021 or 2022...
Oh, it would have made catastrophic financial decisions because they didn't know the fundamental rules of the global economy had changed.
And that is data drift.
That's data drift. The model doesn't know it's wrong. It will confidently continue to spit out highly precise, mathematically sound predictions that are completely detached from current reality.
It's a ticking time bomb buried deep in your own automated business logic. That is wild.
Which is exactly why a model without a pipeline is a liability, not an asset. If we connect this to the bigger picture, to survive no man's land, you don't just need an interface. You need an automated MLOps pipeline.
MLOps, machine learning operations.
Exactly. A system that watches the live data feeds, detects when the model's accuracy drops below a certain threshold, and automatically triggers a retraining sequence using fresh data.
So knowing a model will rot without constant pipeline engineering is, I guess, half the battle. But what does successfully surviving no man's land actually look like in practice?
Well, to understand the massive strategic value of getting this right, we need to look at an industry where waiting 2 days for a data scientist to manually update a slide deck means losing millions of dollars.
Right, the consumer packaged goods industry, the CPG case study.
Yeah, CPG is arguably the ultimate stress test for enterprise AI. The volume of data they process daily is staggering.
Yeah, globally complex supply chains, incredibly thin profit margins on individual items.
Exactly.
Think about your own Fridays if you're a business leader in this space. The case study outlines this infamous Friday panic. Oh, the Friday panic is so real.
You're sitting on an absolute mountain of disconnected intelligence.
Yeah.
You have live point-of-sale data streaming in from thousands of retail locations showing exactly what's moving off the shelves today.
Right.
You have separate vendor reports showing where your media and marketing dollars were spent this week. You have spreadsheets tracking competitor promotions and warehouse inventory levels.
And the nightmare is that data lives in completely different silos.
Yes.
The POS data is in one proprietary dashboard. The marketing spend is sitting with an external agency.
And the supply chain constraints are probably locked in some outdated enterprise resource planning system.
Exactly. And despite this massive fragmentation, leadership expects you to synthesize all those signals and make a definitive call on resource allocation by the 4 p.m. Friday strategy meeting.
It's impossible. You are essentially staring at 5 different screens, trying to do multidimensional calculus in your head.
Right.
Just to figure out if you should, shift marketing spend away from the Northeast and put it into the Midwest to support a lagging product launch. And that manual reconciliation, that is where businesses lose their competitive edge. And this is where the case study introduces a radical shift in how we deploy AI.
Okay. What did they do differently?
The goal of their most successful project wasn't to build another isolated dashboard to add to the pile. It wasn't to give the executives another static report. The goal was to build an integrated decision engine.
So they prioritized the system over the model.
Yes.
And they did this by treating deployment like a special forces operation, right? They realized they needed a dedicated team of engineers who exclusively owned the last mile.
That no man's land between the math and the business user.
Exactly.
When you have a team capable of building the API contracts and the real-time data pipelines we discussed earlier, you stop asking humans to manually connect the dots.
The system actively ingests the POS data, the media spend, the supply chain constraints, all simultaneously.
And it feeds all of that live context directly into the AI models.
Right. Because they successfully built the bridge, the business leader isn't calling a data scientist for custom query anymore.
No, they are sitting at a unified interface. They're asking the system the exact questions they need to survive the quarter.
Like, which specific stores have the highest upside potential right now based on localized weather patterns and competitor stockouts?
Or where should we place our very next dollar of digital ad spend to drive the highest incremental sales?
And they get the answer in seconds, not days.
Seconds. Because the ultimate advantage in an industry like CPG isn't having a slightly more accurate predictive algorithm. The advantage is speed.
The team that spots a microscopic shift in market demand, measures the implications across their entire supply chain, and redirects their resources faster than the competition, they win, full stop.
They do. The organizations that transition from static, siloed reporting to continuous integrated opportunity detection, they're operating at a fundamentally different velocity.
While competitors are manually updating spreadsheets for a quarterly review, these teams are executing on live market signals. So what does this all mean for you and your own teams? If you've been listening to this and recognizing the symptoms of those zombie projects,
Yeah, if you have brilliant technical talent doing incredible work, but the operational impact just isn't there.
The core takeaway is a massive shift in perspective. The critical handoff isn't just a minor administrative hurdle that you can delegate to a generic IT ticket. The handoff is the entire game.
It really is.
If a model doesn't cross no man's land, the investment is zero. You have to stop presenting results, and you have to start shipping product.
Which requires an honest audit of your organizational structure.
Yep.
You have to look at your data science pipeline and ask, who is specifically assigned to own the deployment?
Right.
If the answer is, oh, we assume IT will handle it, or the data scientist usually figures it out, then your models are already at risk of rotting in the repository.
And that leads me to a final thought I want to leave you with today, a concept to just mull over as you evaluate your next major technical hire. If the fundamental failure of enterprise AI isn't the math, but rather the organizational gap of no man's land, then perhaps the era of the data scientist as a solo hero is officially over.
Wow. Yeah.
If the true measurable value of AI is only unlocked by the user interface, the rigorous API contracts, the automated drift monitoring, and the deep system integration, then maybe the most vital hire for your company tomorrow isn't the lone genius who builds the algorithm.
Right.
Maybe it's the specialized engineer,
Yeah.
the architect who builds the bridge so the rest of the company can actually cross over and use the tools. You have to ask yourself, are you structuring your teams around isolated builders, or are you prioritizing the bridge makers?
It is a profound distinction to make. An isolated builder, no matter how talented, will inevitably give you a ghost in the repository.
Yeah.
A bridge maker gives you a scalable business capability. So look for the disconnected signals and the friction points in your own Friday meetings. The opportunities for integration are everywhere.
They really are. So go find those master chefs locked in their apartments, break down the door, and let's actually get that food out to the dining room. Thanks for joining us on this deep dive. We'll see you next time.